Limits of functions as x approaches infinity. We're asked to evaluate the limit as x approaches infinity in each of these algebraic fractions. Neither fraction reduces down to any simpler form. Before I formally evaluate these limits, it's worth noting that the calculator could be used to give us a very good idea of the answer. So if instead of x you inputted a large number, you can't input infinity, but even inputting 9,999 would give us a very good idea of these solutions. So the limit of the first one seems to be 2, and the second one seems to be 0.6. We'll try this now with a more formal evaluation. So this is how we'll do this. We're going to take advantage of the fact that the limit as x approaches infinity of 1 over x is equal to 0. So if we could write each of the terms that have each of the x expressions as a fraction where x is a denominator, well then we could take advantage of this fact. So if we divide above and below the numerator and the denominator by x, or multiply by 1 over x, this becomes 4 plus 1 over x being divided by 2 plus 3 over x. Now the limit of this, as x goes to infinity, becomes 4 plus 1 over infinity divided by 2 plus 3 over infinity. So this equals 4 plus 0 divided by 2 plus 0, which is 4 over 2, or 2. So the limit is 2. In this second example, we have a quadratic expression being divided by another quadratic expression. Dividing above and below by x won't create x as a denominator in each expression. So what we're going to do this time is multiply above and below by 1 over x squared. Because if the limit as x goes to infinity of 1 over x equals 0, well then logically the limit as x goes to infinity of 1 over x squared must also be 0. So that's what we're going to do. So each term is being divided by x squared. So this now becomes, the top is 3 minus 2 over x plus 4 over x squared. And the denominator becomes 5 plus 4 over x minus 3 over x squared. And if we consider each of these terms now as x approaches infinity, we're going to be left with 3, taking away a 0, adding a 0, 5 plus 0 plus 0. So this gives us a limit of 3 over 5.